Hello, my name's Aaron Steinhauer. I'm a professor of physics and astronomy at SUNY Geneseo, and this is a video I'm making to get you informed and excited about the total solar eclipse that's coming to our neighborhood on April 8th, 2024. Let's get to it. What are we looking at here? This is a photograph taken from space of the Earth during a recent total solar eclipse. What are we looking at here? We've got the continent of Australia down here. This is the opposite side of the Earth from Geneseo. Here's Indonesia, Thailand's up here, China, and Japan up here as well. This is the area of the total solar eclipse itself. What are we looking at? This is the circular shadow of the moon as projected onto the Earth during this total solar eclipse. The sun and the moon were perfectly lined up with the Earth, such that the shadow, the umbra of the moon's shadow, falls directly on the surface of the Earth. That's what a total solar eclipse is. The umbra is the region of the moon's shadow where the entirety of the sun is blocked out. The penumbra is going to be much bigger than that, and you can't really see it in this photo, the region where the sun is partially blocked out. So people in northern Australia were likely seeing a partial solar eclipse at the moment that this picture was taken, but the only people, or fish or dolphins, who are seeing the total solar eclipse were out here in the middle of the Pacific Ocean when this particular image was taken. Now, this shadow is not standing still. The Earth is spinning on its axis, the moon is going around the Earth is going around the sun. Everything in space is constantly in motion, and this shadow, because of the moon's orbit around the Earth, is actually moving quite quickly across the surface of the Earth's face. This is what's coming to us on April 8th. The path that the sun is going to take on April 8th is going to look something like this. Again, the moon's shadow looks roughly circular on the surface of the Earth, but it's going to move through this path over the course of April 8th and hitting lots of major metropolitan areas, including ones around us, Buffalo and Rochester, pretty much smack dab right in the middle of this particular eclipse. Here's zooming in on Western New York, what that's going to look like. Again, this is at any instant where the shadow is going to be. At 3:15 p.m., it's going to be over Cleveland. 5 minutes later, it's going to be over Buffalo. 5 minutes after that, it's going to be over northern New York. And 5 minutes after that, it's going to be over northern Vermont and New Hampshire and southern Canada over here. And where are we? Geneseo is right there, just south of Rochester. We are very, very lucky to be in the complete and total path of this eclipse. People living in Ithaca and Elmira and Binghamton and Schenectady and Utica are not going to see a total solar eclipse on April 8th, 2024. Only people who are between these two lines will get to experience the amazing event that is a total solar eclipse on April 8th, 2024. Okay, so what are you going to see? What should you expect to see on April 8th, 2024? Well, even before totality hits, we're going to get about 70 minutes of a partial solar eclipse. And there's some interesting and cool things to see even during the partial solar eclipse. So let's get into that first. This is a picture taken about halfway through a partial solar eclipse. You can see the moon. Here is this circular object blocking the sun's surface. This kind of looks like a crescent moon, but this is in fact the surface of the sun being blocked out partially by the disk of the moon passing in front of it. And even during this point, you're going to see some odd things happening around for a little more than an hour from the beginning of this happening until totality hits on that Monday afternoon. So let's take a look at some of those things. And there are ways that you can safely observe this on April 8th, including the use of a pinhole camera, right? What's a pinhole camera? A pinhole camera is any device, really, that blocks out all of the light except for a very small point. And when you do that, it makes a very nice image projected on the ground or any other surface that you desire of the thing that's causing the light. In this case, the sun. And so this is an image that was taken by somebody's hand who made a little pinhole camera with their fingers. And what do you see here? A beautiful crescent eclipsed sun, an image of that eclipsed sun projected onto the ground. This is a safe way. Obviously, you're not looking right up at the sun. Please don't look right up at the sun. It's dangerous. It can hurt your eyes fairly quickly. But there are safe ways to do it, and this is one of them. Create a pinhole camera with anything, even your fist, and you'll get a nice image of the eclipsed sun, and you can follow its progression as the moon slowly passes in front of it. Other household items you might be able to use to do something like this, like kitchen strainers. Right here you have a pasta strainer, and you can see somebody has taken this out and put it over the ground during a total solar eclipse. And what do you get? You get lots and lots of images of the eclipsed sun, one for each of the mini pinhole cameras on the pasta strainer itself. And you can play around with this. If you put this, raise this up a little bit, the images are going to get larger. If you move it closer to the ground, the images are going to get smaller. And you can use any household objects like this, maybe a cheese grater, to make mini pinhole cameras and follow the progression of the eclipse without staring directly at the sun. Of course, if you have eclipse glasses, you're welcome to stare directly at the sun and watch this directly. Other things are going to make natural pinhole cameras in our environment. This is one of the cool things. Even if you're walking around on a sunny day during an eclipse, the sunlight filtering through the trees will create mini pinhole cameras that will create dozens, perhaps hundreds of images of the eclipsed sun. This is an image that was taken during a partial solar eclipse, but very close to totality. You can see how thin this crescent is and how close the moon was to completely blocking out the sun. And you'll see this even walking around on a sun. If April 8th is sunny, you'll see this happening all over the place as sunlight filters through the trees and makes these mini pinhole cameras. All right, but that's not what you're here for. You're here for totality. We live in the path of totality, and that's when the real action is going to happen. The total eclipse itself is one of the most amazing things that you can witness in the natural world, and you're not going to want to miss it on April 8th. So what are you going to see? Well, even before totality hits, in the minute or so before totality hits, you're going to see something that looks like this. What are we looking at here? Again, it's the moon and the moon passing almost directly in front of the sun, but this is an effect known as the diamond ring effect. And you'll notice the edge of the sun is still a little bit poking out from behind the moon, and it makes this stunning diamond ring effect, where you get the diamond over here and the ring going over here, and it looks a lot like a diamond ring. That's in 30 seconds to a minute before totality. Even closer totality, we're talking about in the few seconds right before totality hits, you're going to see something that looks like this. This is an image that was taken in 2017, 4 seconds before totality hit. And again, we're looking at the edge of the sun just poking out from behind the lunar disk. But you're noticing some very interesting things here as well. This is a phenomenon known as Bailey's beads. And you'll see light poking out from the sun in places that you might not have necessarily expected it to, given the geometry of what we're looking at. Why is it that you're seeing sun streaming through there, but you're not seeing sun where you would expect it to right next to it? The answer is that the lunar surface is not a completely smooth thing. There are craters, there are mountains, there are hills, and there are valleys. Why are we seeing the sunlight there? It happens to be streaming through a valley on the lunar surface. Why are we not seeing the sun surface right there? Because there happens to be mountains and hills that are blocking the view of that particular part of the sun. And same thing over here. You've got some lowlands where we're actually seeing the sunlight stream through, and some highlands where it's being blocked out. This is going to happen over a few seconds right before totality, right? These beads are not going to last long. In the next second, that one's going to go away, but what's going to happen? Another one might pop up over there instead. And so this is going to be a constantly changing thing, again, in the several seconds right before totality hits. All of this time, you've still got your eclipse glasses on. At this point, the pinhole camera isn't going to do you much good. You need your eclipse glasses, and you're going to be watching the diamond ring effect and these Bailey's beads with your eclipse glasses. Now, seconds after this happens, boom, totality hits, and at that point, you can take off your glasses. The harmful light of the sun is no longer there, and you're going to want to, because your glasses are going to be really dark and you're not going to be able to appreciate any of the things that come later if you keep them on. So take your glasses off, and what are you going to be seeing at that point? The first thing you're going to notice is that the surface right around the eclipsed sun has a very pink ring all the way around it. What are we looking at here? This is the layer of the sun's atmosphere called the chromosphere, or literally the sphere of color, and it's pink because it's hot hydrogen gas that's been lifted off the surface of the sun. And hydrogen gas, when it heats up, it glows a very characteristic pink color. What are we looking at here? Magnetic fields on the surface of the sun are interacting with the plasma there and pulling it off in giant loops of material and shooting it out in jets and flares of solar material off the surface of the sun itself. So how big is this? It's hard to really grasp the enormity of the sun, but if the Earth were in this picture, it would be something like this. It would probably fit inside this loop of material right here. The Earth is about 100 times less diameter than the sun. 100 Earths could fit from one side or the other. The Earth would probably comfortably fit inside that loop. And the nice thing is, we're coming up on solar maximum, which means the sun should be unusually magnetically active compared to the rest of its 11-year cycle on April 8th, 2024. What does that mean? It might mean we get even larger of these loops. It might mean we get even more intense activity happening on the surface of the sun, and we can all hope for a nice show on April 8th. What else are you going to see? So stare at that. That's going to be amazing. Zoom back a little bit, and you're going to notice that the entire area around the sun is covered in a halo. And this is another layer of the sun's atmosphere called the solar corona, or literally the solar crown. And this is, again, charged particles near the surface of the sun being accelerated by magnetic fields and streaming out along these magnetic field lines in the solar wind. And so that's going to be a spectacular thing that you're going to see. Immediately, what you're going to notice when totality hits is the sun and all of these layers in the sun that are always there, but you can never see them except during a total solar eclipse. What else are you going to notice? It's going to get dark. Stars are going to come out. So we've got about 3 minutes of totality here in Geneseo. Take a couple minutes at least and just stare at the marvel that is the eclipse sun. But once you've had enough of that, kind of pull your gaze back and notice that the stars have come out. You're going to see some, not only stars, but some planets. Here is what are we looking at here? We're looking due south at the moment of the eclipse. This is created with stellarium. This point, this green plus up here is the zenith, the point directly overhead. And this is what the sky will look like on April 8th, 2024 during the solar eclipse. Here is the sun and the moon, almost due southwest, about halfway between the horizon and the zenith. That's where this is where you're going to be pointed anyway. This is where you're going to be looking. This is where all that pink ring and corona is going to be showing up. But if you look elsewhere, you'll notice a very bright star up and to the left of that. That's the planet Jupiter. There are other planets in the sky. Down to the right, you'll see the planet Venus. And near the southwestern horizon, you'll even see the two bright stars, which are actually the planets Saturn and Mars. And they're all lined up, look at that, in the plane of the solar system. So that's something to look for on April 8th as well. There will also be a comet in this picture. There's a comet Tolpe-Pons-Brooks 2024, which is going to be there. It probably won't be visible, but if it gets unusually bright sometime between now and April 8th, it's possible that you also see a comet between the Jupiter and the eclipsed sun right there with its tail kind of pointing away from the sun and the moon this way. So if we're really lucky, we'll be able to see that as well. And of course, you've got all the stars that have come out. Here's the constellation Orion with the three belt stars, Betelgeuse and Rigel. There's Sirius, the dog star. Here is the constellation Taurus, the bull, and Aldebaran. Gemini is up here. All of these things that you're going to normally can't see during the day, you'll be able to see at about 3:30 p.m. on a random Monday in April. So that's going to be very exciting. What else is going to be happening? This is a total multi-sensory experience. You're not just going to be seeing things. You're going to be hearing things. You're going to be feeling things. Nature itself is going to be freaking out at this point, right? All of the clues that animals use on when to get up and when to go to bed are based on the sun. When it gets light out, the daytime creatures emerge. When it gets dark out, they go to bed. This is going to be freaking nature out. The daytime creatures are going to be going back to their dens and nests. The nighttime creatures are going to be coming out. You might hear crickets chirping. You might hear owls hoot. All the nighttime sounds that you normally hear, you're going to be hearing during that 3 minutes potentially. And all the daytime sounds are going to stop. You're going to hear things differently during these 3 minutes. People are going to be acting weird. Even if you know what's coming, this is such an awesome and amazing experience that people are shouting and screaming. You're going to hear all kinds of things going on that are unusual during the moments of totality. You're going to see things, you're going to hear things, you're also going to feel things. The sun's going to be blocked out. It's going to feel colder because that sun's light from the sun is being blocked out. The winds might pick up or shift directions as the temperature changes affect the airflow in the atmosphere. This is a complete, total multisensory experience. You're going to see things, you're going to hear things, you're going to feel things. It's one of the most amazing and awe-inspiring events that you can witness in all of nature. All right, so that's what you need to know about what's going to be happening during the eclipse. Now you need to know how to stay safe. I've mentioned this before, but it's worth repeating. Don't ever look at the sun when it's not in total solar eclipse. It can hurt your eyes in a matter of seconds permanently, and if you stare at it for long enough, you can actually go blind. When the sun is not in a total solar eclipse, obviously never look directly at it, but you can use eclipse glasses if they have the right rating, or pinhole cameras as we described earlier. Now, once the total solar eclipse happens, it is safe to remove your glasses, but you're going to want to set a timer. And I'll talk about this and how you can look up what to set it for, because it's not going to be obvious when the totality is going to end. And even those Bailey's beads and the diamond ring effect with just part of the sun poking out is still bright enough that they can damage your eyes, and you want to know when to put your glasses back on. Other recommendations, and this is really important, feel free to take pictures during partiality. You've got over an hour at the beginning before totality hits, and over an hour at the end after totality hits, where you can mess around with your phone and try taking some pictures if you want. I wouldn't point my phone or camera directly at the sun unprotected, but if you've got a small enough lens, like on your phone, you can put your eclipse glasses right over the lens of your phone and take a picture. In fact, this picture was taken during a partial eclipse with exactly that arrangement in mind. Here is my best advice to you. Don't try to take pictures of this thing during totality, especially if this is your first eclipse. Two things. One, the pictures are going to be disappointing. It takes some very fancy professional equipment to really be able to capture what you're seeing in any decent way. And two, this is one of the most amazing things that you can witness. You're not going to want to be futzing around with your phone or camera or trying to get the perfect shot. You're going to want to be taking this in. You're going to want to be in the moment. You're going to want to be experiencing all of the things that this 3 minutes, the very rare 3 minutes, has to offer you. So don't try to be doing anything during that time. Just sit back and experience it and enjoy the amazing event that is the total solar eclipse. All right. So this is an extremely exciting thing. It's coming to us on April 8th, 2024, and it's a very rare event. How rare is it? On average, any particular location on Earth sees a total solar eclipse only once every about 375 to 400 years. This is an extremely rare event to occur at any given location on Earth. They happen about once or twice a year anywhere on Earth, but as you can see, the people for any given eclipse who can actually see that particular eclipse is very small and is limited to be the narrow path that shadow happens to take across the surface of the Earth on that particular eclipse. This is it. This is the only eclipse that is coming to Geneseo in our lifetimes. This is our total solar eclipse. You don't want to miss it. Okay, other things that you might want to know. We put together a web page. You're welcome to browse it, eclipse.geneseo.edu. It's got a lot of good stuff on there. I'm going to show you briefly what's on there, but more importantly are some links I'm going to show you later about the timing of the eclipse. Okay, here is that web page. You can see a nice animation of what it's going to look like as the moon slowly passes in front of the sun. We've got the total solar eclipse and all about eclipses over here, and lots of links basically with information that we've already given you in this video about how the shadow is going to move and what to expect to see and the timing of things. But I want to point out some links that are going to be extremely useful to you as you're planning your eclipse day. The scientific, local, and campus resources are here, and here I've got an interactive eclipse map linked. This is a a website put together by the National Solar Observatory that includes an interactive map that you can use to plan your day. Let's take a look. Here is that eclipse. We can see a countdown timer, and most importantly, a map, an interactive map showing the entire path of the eclipse, or at least part of it. The green line is the center line of the eclipse, and in between the red and the blue lines are where you can see a total solar eclipse on that day. The greatest eclipse is going to be here in central Mexico. We are up here in western New York. I'm going to change the satellite view and zoom in on Geneseo, and you can see how useful this is going to be. So where am I going to be on April 8th, 2024? Well, if it's clear, I'll be right here on the Log Cabin Park. If it's not clear, I probably won't be here because we are, this is such an amazing event. You want to go to the place where it's clear. If it's cloudy, almost none of the things that I've mentioned are still going to be happening. And it's going to be a very disappointing day. But if it's clear, we will be having, the college and the village will be having an event at the Log Cabin Park in Geneseo. You're welcome to join us. We'll have bands, there'll be concessions set up, lots of things going on. So I'm gonna click on the Log Cabin Park field, in fact, right in front of Doty Hall, and I'm going to show you what the information it's going to tell you. For this particular location on Earth, when and where the eclipse is going to happen. The partial eclipse will begin here at 2:06 p.m. 73 minutes later at 3:19 p.m. totality will begin. It will end about 3:23 p.m. Totality, and the partial eclipse will end totally at about 4:30 p.m. on April 8th. This is also telling you where in the sky the sun is going to be at each of these points. Altitude measures degrees above the horizon, right? So 0 degrees is right on the horizon and 90 degrees is the zenith. At totality, the sun is almost exactly 45 degrees up in the sky. It's almost exactly halfway between the horizon and the zenith. Azimuth measures the location east-west in the sky. 180 degrees is due south, 270 degrees is due west. Southeast is exactly 225 degrees, and that's pretty much where it's going to be. So it's going to be almost exactly halfway up in the sky at almost due southwest. How long is totality going to last? This is the most important piece of information on this site. Not 3 minutes, not 3 minutes and 13 seconds, 3 minutes and 13.5 seconds. Why is this useful? Again, you're not going to know. It's not going to be obvious when this eclipse is going to end, right? So what should you do? If I'm at this exact location on April 8th, I'm going to set my timer for exactly 3 minutes and 10 seconds. And then what's going to happen? I'm going to be looking at the partial eclipse, and it's going to be getting closer and closer, and I'm going to see Bailey's beads, and I'm going to see, and then bam, totality is going to hit. What am I going to do? I'm going to take my eclipse glasses off, and I'm going to start that timer. And now I've got 3 minutes and 10 seconds. I don't have to be thinking about anything. I don't have to be worrying about when this eclipse is going to end. I don't have to be checking my watch or my phone constantly to figure it out. I'll have an alarm that's going to go off, and when that alarm goes off, I know I've got 3.5 seconds to find my eclipse glasses, put them back on, and now I'm going to see Bailey's beads and the diamond ring going in the other direction. So that's my advice to you. Wherever you're at, if you're over here on Naga Field, you can see it's going to be a tenth of a second shorter at that point. This is that micro, it's that precise on where these locations are and how long totality is actually going to last. All right, I will stop there. Best of luck to you. I hope for clear skies and happy viewing on April 8th, 2024. And enjoy this total solar eclipse. This is the only one that's coming here in your lifetime. So long.